Now this is a question number 4, which is a little bit different. Okay, so here I'm going to tell you how will you solve this question. So this question number 4 of exercise 4.5, verify that A adjoint A, that is equal to adjoint A into A. Okay, so here there is difference of order. Okay, and that is equal to A determinant into I. So all the three things we have to prove that all the three parts are equal. So it's very easy. A's matrix is given to you. Okay, you can find out the adjoint of this. Okay, first write A element. If you have to solve this, A you have to take this side, A into adjoint A. Okay, so A into adjoint A you can calculate. So then you have to multiply in the same order. First you have to write the A, then you have to write adjoint A, and then you have to find out the product. So I know you can find out the product of two matrices. Fine. After that, if this is given to you first you have to write adjoint A, then A. First you have to write the matrix of adjoint A, then A, and then you have to find out the product. Okay. At last, in third part, you will take A determinant into I. A determinant first you have to find out, and then I determinant, identity matrix. Okay, so A determinant you can calculate, and I is given to you. I is identity matrix. So as you know that I is equals to 1 0 0 0 1 0 0 0 1. This is the value for I. You have to write this value at a place of I, and A determinant you can calculate finally after evaluating this. And if all the three parts are equal, then it's verified. Okay, so this is how you can solve question number 4. Okay, and here is a next question of this exercise 4.5, that is question number 12. So here two matrices are given to you, A and B, both the matrices are given to you, and you have to verify that AB, inverse of AB, that is equal to B inverse and A inverse. Okay, so what you have to do, you have to take left hand side first of all, A into B, this side. Now you have to find out the product of this first. Okay, AB. Find out the product of AB. Fine. For example, if you have to find out the product of AB, you will get C. Here AB, we are just finding out the product of AB, and after calculating this you will get this. Okay, AB is given to you, and we are assuming that this AB is equals to, this is the product of AB, and this is a single matrix we are getting after product, and I am assuming that is equal to C. So here is a product of AB, that is this matrix, and is equal to C. Okay, now if this is a C matrix, we are assuming that here, and you can find out the inverse of this. Okay, so whatever be the inverse will come, you have to write here. And then in the right hand side, what you have to do, right hand side, what you have to do, you have to find B inverse and then A inverse. First find B inverse, then find A inverse, and after calculating this you have to find the product of both, and you will get a matrix. Okay, and this matrix and this matrix should be same. C inverse, the C inverse must be same. Okay, the C inverse, C is there, so you have to find the inverse of that. So whatever the matrix you will get in C inverse, that must be same with the product of these two matrices. And this is how we can solve. Okay, hello everyone, this is your question number 13 of same exercise. Fine. So here A matrix is given to us, and we have to show that A square minus 5A plus 7I is equal to 0. Okay, first we have to prove this is equal to 0, and hence we have to find A inverse using this equation. Okay, so here's the solution. First of all, what I'm doing, I'm finding A square. So A square can be written as A dot A. This is a matrix A, this is another matrix A. You can find out the product of these two, and you will get this 8 5 minus 3 minus 5 and 3. This is a product, that is A square. Okay, So in left, we are taking the left hand side of this equation. We have to prove this is equal to 0. So we are taking the left hand side. That means here we are taking a square minus 5a plus 7i. So here it is. This is I. Okay. So this is the value of a square, 5 and 5 will remain same. Here is the value of a plus 7 7, and here is the I is the value of I is identity matrix. So here is the value of identity matrix. And just what you have to do, I'm copying it here. I'm inserting 5 here and multiplying this by 7. So you will get these two matrix. Okay. Then what I'm doing, I'm adding this and this matrix. After adding, you will get this. Okay. And minus this matrix. Okay. Addition, subtraction I'm not explaining because I know you can solve it. Okay. So you have to subtract. So you at last you will get 0, which is the right hand side. Fine. And hence proved. And the next part, that is very important. You have to understand it. Okay. How we can find out A inverse using this equation. Okay. So here is the equation. That is equal to 0. What we are doing, I'm just multiplying both sides by A inverse. Okay. So when you multiply this equation by A inverse, A square into A inverse minus 5A into A inverse plus 5 into I into A inverse. When you multiply any matrix with I, you will get the same matrix, that is A inverse. Okay. That is equal to 0. Okay. Then A square into A inverse, that would be A. Minus A into A inverse, that is 1. So we cannot leave 5 alone. So we have to write identity matrix with it. That is I. A into I inverse, that is I. So you can say that the value of this is I. Okay. Plus 7 into A inverse, that is equal to 0. Okay. After that, leave it here. We are you have to write 5i on the right hand side and A on the right hand side, that will be negative I. Okay. So we are just changing the place from left hand side to right hand side. We are taking this 5i and A. So you will get this step. Okay. Now your I is identity matrix. You have to just put the value minus A matrix is given to you. Here it is 5A 7A inverse, insert 5. You will get this minus and the same matrix will be here. Okay, now you have to subtract these two. 5 minus 3, that would be 2. 0 minus 1, that is minus 1. 0 minus 1, that is 1. 5 minus 2, that is 3. So this 7 will, you can write 1 by 7. It will come here it is multiplying, to here it will divide. So 1 by 7 in the same matrix. So this is the A inverse using this equation. Okay. Okay, bye bye, take care.